All right, guys, we're going to practice using two-step equations. You're going to need your hanger models handout that we've been working with this week. We're going to skip around. We're not doing all of it, but you are going to do this and then turn it in today once it's done, because I am going to give you a daily grade for getting it done. You also are going to need your OMG with your little expressions flow map, with your flow map on it. I'm going to get me one of the little ones like yours so that maybe I can get most of it into the camera screen. All right, so sorry, I know my camera's shaking. I'm trying to make sure I get everything in focus. So this is yours. Some of you got it colored, some of you don't. All right, so we're going to start. I want you to go to slide 7. We're going to start on slide 7. I'm using the handout that is just like yours. Now, I did redo this a little bit, and I'll talk to you a little bit about some of the changes that I made. But we're going to use the slide I'm going to use the handout that matches yours, okay? I got all of my erasable pens. Can y'all see all those? And some of them don't write real good, though. These are my favorite, I think. I like the clicker ones like this with the clicker on it, but we're going to, I'll be doing lots of color. So we're going to be looking at this, and I'm going to go through solving the two-step equation with you doing this, okay? And we're going to kind of look at how it works with your with your flow map, your solving equations with your, we're going to call this our mini mega map. This is our mini mega map. The mega map's hanging on the wall, and this is your mini mega map, okay? So I'll just be dragging that over, pulling it in as we use it. So on this, what I want to explain to you about this and what I didn't like about this is this balance is actually balanced. This is the inaccuracy here on this activity, and it was put out by the State Department of Education. This is not something I made, but the inaccuracy here is this is balanced. It's actually balanced. So if you want to take your pencil or something, all right, now pen. Are you kidding me? Okay, that one's going in the trash because it ain't writing. These are the ones that I got online, and I don't like them as good because they don't write as good. We'll try it. Let's see. We're going to balance this. It is actually balanced. And we're just going to mark out the word not. It is actually balanced because it's balanced because Z is identified right here. Now let me see. I'm going to move this over. I noticed today watching a video, I keep putting my hand in the way and you couldn't see what I was writing. So I'm going to try to be more mindful of that. But Z is actually, because of this Z right here, because we gave those triangles a value, it actually is a balanced equation, okay? Now this first question is asking you to record the value to balance the equation, which really that should say, what is the value to keep this balanced, not to balance it. But we're not going to split hairs, and we're going to use these equations because they are good. It's good for you to see that we're going to start with an equation that's balanced, and then we're going to have to use our steps to keep it balanced. Our goal is to keep constantly balanced, okay? Couple of things before we get started. If you'll take your little mini map, your mini mega map, and there's a couple of things that are not on here that are on the mega map. And one of them is down here for use inverse operations to zero out the constant term. this is going to be an undo and balance. We will undo and balance at this step. And we will also undo and balance on this step. So it's an undo and balance, okay? Another thing that we need to keep in mind is that we are going to, so our steps are, if necessary, we use the distributive property. When we do the distributive property, if we do it, we're going to have a new equation right here. New equation. We're going to write a new equation. Then we're going to have our constant terms and our variable terms, and we're going to label those. Then we're going to use combining like terms, and we need one C and one V. And here, if we do this, again, we will have a new equation. We will have another new equation right here. Then we're going to use our undo and balance to zero out the constant term. And then we're going to use our undo and balance. And if we do this and are not finished, one more time, we're going to have a new equation. And you'll see what I'm talking about in just a minute. We're going to have a new equation, okay? Our ultimate goal, when we get down here to the end, the be-all, end-all, what we want at the very end is a variable with a +1 coefficient. And I'm going to just abbreviate coefficient. A +1 coefficient with our variable. That's what we want to have, okay? So, coming back to this. This is a balanced equation. So, the first thing it's asking you is, what value can you give to Z? So, let's look at this. If you look at this and you pretty easily can see that Z is going to be, we've got 3 over here, 21 over here. So if I subtract 3 from 21, and I'm just going to kind of write some of that down. So 21 minus 3 is 18, okay? And now I've got these two together are going to be 18. And so if those two together are 18, if I divide 18 by 2, that's going to make this one 9 and this one 9. And if you add 9 plus 9 plus 18, 9 plus 9 plus 3, you get 21. So this value over here is 21. This value over here is 21. So therefore, it is balanced. So Z equals 9, okay? Z equals 9. Now, it wants to know what equation would match this. What equation would match this? And I don't know why if you notice right here, this one is balanced. See how that one's balanced? This one should have been up here because this is a balanced equation. It's balanced because there's a value for Z. But so we start with a balance. The thing I want you to remember is we're going to start with a balanced equation. So here's what we're going to put. We're going to start with a balanced equation. We're going to keep it balanced. To solve for the variable. So if you need to, take a minute, pause, and write that down. We're going to start with a balanced equation. Then we've got to keep it balanced to solve for the variable. Okay? So down here it's asking you to tell me what is the equation that you see. What equation do you see right here? So what we see here is what do I have right there? I have two z's. I have two z's. And I have a 3. So we can easily see that 21 is equal to, because this is going to be equal to this, equals 2z plus 3, okay? Now we're going to take this equation and we're going to put it through our steps, okay? And to see how these steps work. We know what the answer is going to be, but I want you to see how this is going to look and what we're going to do to solve it using our steps, okay? So I'm going to be changing up colors all the way around so I'm going to take this equation, I'm going to write it right over here. 21 equals 2z plus 3. Now, in order to get full credit on this activity, you're going to have every single thing that I write on this piece of paper needs to be written on your paper. It can be written in pencil. You ain't got to change out all these colors and do all that. I'm doing that to help you, and and it's easier when I post it on Google Classroom for you. You can do it with a pencil, but you need to be, it's got to all be there. Everything that I'm putting on here has got to be on your paper for you to get full credit. All right, so now we're going to take this through our steps. So we're going to find the expression. Well, here's our expression right here. This is our expression. This is just a constant term, but this is our expression, okay? That's our expression. It says, if necessary, we're going to use the distributive property. We have no distributive property on this one. So there's no distributive property, so we skip that step and we go to the next step. Label the constant terms and the variable terms, okay? Let's define constant term and variable term, all right? Let's define that. I'm going to come, let's see, I'm going to go right over here. We're going to do constant term come on now. These pens don't write them, throw them away. Constant term. And the easiest way to remember a constant term is it's just a number. Constant term is just a number. The variable term is going to have a letter. The variable term is going to have a letter with it. Okay, so over here, we're looking for our constant terms and our variable terms. 2z is a variable term, so we're going to put a v around it. Plus 3 is a constant term. And we're going to make sure to pick up that plus sign with that 3. Make sure to pick up that plus sign with that 3. Okay? 2z is a variable, plus 3. Now, we've done that. So we identified our constant terms and our variable terms. On the mega map, you will, if you've paid any attention to the mega map, you notice it says we have to have one C. We need one C and one V to move. We got to have one C and one V to move on. So look over here. Do we have one C and one V? Yes, we do. So we're ready to move to the next step, which is combine like terms. Combining like terms, well, that's, God, I wrote that in the wrong place. I'm sorry, y'all. I'm sorry. And if you fix it, and this step is where you need one C and one V. I thought I had that on the map, and then I wondered why I didn't see it. And it's because I was looking at the wrong step. You need one C and one V to proceed. Okay? That's critical. That's critical. One C and one V. We have one C and one V. So now we're ready to go here. It says use inverse operations to zero out the C constant term. We're going to go to the constant term, which is here. Here's my constant term. To undo and balance. So I'm going to undo on this side and balance it and keep it balanced over here. Whatever I do over here, I have to do over here. We're always going to work off of the side where the expression is. So I'm going to undo this plus 3. I undo a plus 3 with a minus 3. We're zeroing out. If you look at your map, we're going to zero out. Zero out the C. We want to make it a 0. So I've got a plus 3 gets a minus 3. If I put a minus 3 over here, I come all the way to the other side of the equal sign and put a minus 3. Now, last year, I showed some people today. I don't know if I showed every class. Last year, y'all did this. Y'all put a line right there. We're not doing that this year. Last year, that was a good way for you to start learning that there are two sides to the equation. But now in 7th grade, you need to know that this equal sign, that is your middle point. That's your fulcrum. That's the middle. We come to this side of the equal sign to undo. We balance on the other side of the equal sign. So when we do that, this becomes a 0 and it goes away. You could literally turn your C right there, right into a 0, and it goes away. The 2Z, that V is pointing down to show us that we're going to bring it down. And the 21 minus 3 is 18. So we've done this step. We wrote our new equation. Here it is. We needed a new equation. There it is. The next one says to undo and balance to the variable term. So again, we're going to undo on this side and balance on this side with the same thing. Notice here it says do inverse operations. At this step, let me back up a minute and tell you this. Up here on this step, zeroing out will always be addition or subtraction. You're either going to be using plus or minus. You're going to be using positive or negative to zero out. Down here on this step, you will always be multiplying. Y'all know I use parentheses for multiplication. Or dividing. This step's going to be multiply or divide. So we're either going to be multiplying and dividing, having to undo that. So if we look right here, this 2Z is being multiplied, so I need to do the inverse and undo it. Division undoes multiplication. So I'm going to draw my division bar right there. I multiplied by 2, so I'm going to divide by 2. If I divide by 2 here, I have to come across the equal sign and divide by 2 here. Now, when I do that division, 2 divided by 2 is 1. Well, there's my 1Z. There's my 1Z. There's the positive 1 I need with Z. I don't have to show it, but it's there. That's how you get it. 2 divided by 2 is going to give you a positive 1. 18 divided by 2 gives you a 9. And if you notice, this 9 matches that 9. Now, I want to take a minute, and I'm going to grab me some color pencils right quick or some highlighters. I'm just going to do a couple of highlighters. I want you to look at something. Up here, we already said that the first thing we did when we were looking at this is we did 21 minus 3 was 18, didn't we? Well, look at here. There it is. 21 minus 3 is 18. we did the same thing. Then we said that 18 divided by 2 gave us that 9. Well, look here. There's your 18 divided by 2. So you did it up here, but now these are the actual algebraic steps for solving this. This is what you did up here, okay? These are the steps you're going to be showing to solve a two-step equation, all right? So, take a minute, pause this, get all these notes, rewatch this if you need to. This will stay on Google Classroom. If you have to rewatch it at home, that's fine. You are going to turn your handouts in, and then I'll give them back to you in signed papers, and you will have them to use at home to go back through, okay? And I will post a full key of this, even for the ones that we didn't do on this video, because I'm not doing all of these on the video, all right? So then, now we're going to move to slide 9, where it's asking us to first write 2 different equations to represent the hanger. Well, to be honest with you, there are 3 different equations that can be written. We're going to go ahead and write all 3 of them, okay? So the first one's the easiest one, because it's just this plus this plus this plus this. So x plus 1 plus 1 equals 16. That's the first equation that could be written, okay? The next equation we could write, which is the same equivalent, it's an equivalent equation, would be, I have 2 x's right here. I have 2 1s, which is 2 right here. So I could say 2x plus 2 equals 16. That's another one that we could write. But there's one more. And I want you to kind of to think about restructuring this map. This right here for a minute. Imagine if this was drawn and you had x and 1 and x and 1, okay? So I have, this is x plus 1, and this is x plus 1, right? And it's all going to be equal to 16. This is x plus 1, this is x plus 1. So what am I seeing right here? Right here I have 2 x plus 1s that equals 16. So right here you're showing that you have 2 groups of x plus 1. If you remember back to our multiplication from the last unit, when we had think about writing those verbal models, when we did 3 times 2, and we said that was 3 groups of 2. Well, that's the same thing we got right here, guys. You have 2 terms being multiplied right here. So what do you have? I have 2 groups of x plus 1. And so that is the third way that you could write that, okay? Now, we're going to leave that one, and I want us to look at this one. Okay, let's go ahead and look at this one. It says record a value that would no, we're going to find the value that keeps it balanced. Y'all know, all right, so if you know. This is already balanced. It is balanced. We want to keep it balanced, okay? So, it just says record a value. You can get to that value however you want to, but I know what you're going to have to do. We're going to have to subtract. We're going to take 8.5 right here. Why is my voice so hoarse? And don't say under your breath that it's because I yell all day long, because that ain't it. I don't yell at anybody. I just had... But if I subtract 8.5 minus 2, that's going to be 6.5. But I'm going to do it on the calculator just to be sure. 8.5 minus 2. That's 6.5. Now I'm going to take that 6.5. I know that both of these are now going to be equal to 6.5. So I've got to split 6.5 divided by 2 is 3.25. So each one of these x's is 3.25. Those are 3.25, which give us that 6.5. Okay? That's just how you can do that. I don't think, that's slide 10. We're on slide 10. Let me see what slide 11 says. Yeah. Slide, now we're going to go ahead and write this equation, and we're going to solve it, and then we're going to look at how it matches back up, okay? So let's write this equation. What do I have right here? I've got 2 x's, and I've got a 2, and they equal 8.5. So my equation here is going to be 2x plus 2 equals 8.5. Okay? That's my equation. Ooh, I dropped my top. So, from there, we're going to come back over here and grab our mini mega. Our mini mega map. All right, so I'm going to put it right here. You can see this right here, I'm pretty sure. And now we're going to go through these steps. It says find the expression. This is the important part right here, guys. This is what you're going to have to be doing. This is kind of showing you that you can get there. But, you know, looking at this picture, of course, you can get there. But this is the solving of the two-step equation, okay? So, we're going to find our expression. There it is. The expression is it's always going to be where your variables and constants are, okay? So we did that. We don't have any distributive property, so we move on to the next step. Label your constant terms and variable terms. Well, here's my variable term right here. Here's a constant term. So we did that. Move to the next step. Combine like terms if necessary. You got to have one C and one V. You got to have a C and a V to move on. You cannot have more than one. You cannot. You just can't. Okay? We have one C and one V. Check. We now can move to the next step. The next step says to use inverse operations, which is going to be on this step, it'll be an adding and subtracting, to undo and balance the constant term. We're undoing and balancing the constant, okay, which is our C. Our C is a positive 2. So to undo a positive 2, we need a minus 2. This is the undo. That's our undo. I don't want to write that right there. I don't like these pens as much, but this is our undo. We're going to balance by doing a minus 2 over here. Now, when you write that over here, you've got to remember that that's really 2.0. So the 2 has to line up with the 8, all right? That 2's got to line up with the 8. So this is our balance. This is what's keeping it balanced. Because if we took 2 off of here, and didn't do it over here, it's going to go wonk. That's when it becomes unbalanced. When you do something over here and don't do it over here. We start off balanced, and then we've got to keep it balanced, okay? So this became a 0. 8.5 minus 2 was 6.5. This V right here is telling us to bring down that 2x. Now, we're ready to move to this step. We have our new equation. There it is. Now we're ready to move to this step, and we're going to use inverse operations, which will be multiplication or division, to undo and balance the variable term, which is what we've got right here. This is being multiplied. This is 2 times x. To undo this, we have to divide. We're dividing to undo. We're dividing by 2 right here. To balance, we are dividing by 2 right here. When we divide 2 divided by 2, we get a positive 1. So that gives us our x with a positive 1 coefficient. 6.5 divided by 2 is going to give us 3.25. And now if we take our highlighters and we go back and look, we can see that over here, we said, okay, we got to subtract 2. Well, not that 2, but we got to subtract 2. There it is. There's where we subtracted 2. And then we said, oops, sorry. I hit my, sorry. Did I make you dizzy? Okay. Then we said we needed to, then we divided by 2 right here to get that 3.25, and we divided by 2 right there. So we're doing those steps. Okay? All right, so moving on. Now let's look at number 11. We are going to look at number 11 again so that we can, we're going to look at slide 11 because I do want you to be practiced and well-versed in the multiple ways to write these. So, you know, the first and the easiest one, I got my pens all spread out over here. I'm taking up too much room. All right, I'm going to fold my paper in half to give us a little bit more, just to give me a little more room. I just folded it in half. So, now, and for those of you who are not listening to this and maybe just watching what I'm doing on the paper and you're thinking you don't have to listen, just to make sure that I know everybody's listening, I want, right this second, I want you in this corner right here, right over here, I want you to draw me a smiley face. I'm not going to do it on my paper. I'm not going to write anything on my paper. I'm going to just see who is listening, and I want you to draw me a smiley face right over there. Right. Okay? So that's what I want you to do right now. Boom. Thank you. Okay, now, the easiest one to write right here is going to be when we just put these plus signs in between it. This one ain't wanting to write good. Put that plus sign in between it. Y'all know what I did? I think I changed the ink in this to black. X plus 3 plus X plus 3 plus X plus 3 plus X plus 3 equals 24. That's the easy one. That's the easy one. Okay? Now, I personally think the grouping one is the next one that is the next easiest on this one. Because look, they're grouped together that way already. That's an x plus 3. This is an x plus 3. Oops, sorry. This is an x plus 3. And this is an x plus 3. So if I put, I have 1, 2, 3, 4. I have 4 groups of x plus 3 that all equal 24. That's another way to write it. And then the other way would be to say, okay, I have 1, 2, 3, 4. I have 4 x's, and I have 1, 2, 3, 4. I have 4 3's, which is 12, right? So our other way would be to say 4x plus 12 equals 24. Okay? Now, this to me, I think I would call this our, I guess, parent equation. It's not really called a parent equation. It is the equation that we really are going to have to, we've got to get all of our equations to this format, 1C, 1V, in order to be able to solve it. All of our equations have to be in this format. This is what we're wanting. This is the format we want all of them in. But you can get to that from either one of these. And you know what? I'm going to go ahead and show you on here. I'm going to get me a Post-it, a big Post-it right here. And we're going to do these other two equations. And I'm going to show you how they will get to 4x plus 12. Okay? I'm going to show you. We're going to start with this one. You can do this on another sheet of paper. You can squeeze it somewhere. You can, just watch me do it. This is kind of where we're going to go and be on Monday, but this is the perfect spot for me to go ahead and kind of put it out there for you, okay? So we've got x plus 3 plus x plus 3 plus x plus 3 plus x plus 3 plus, 1, 2, 3, 4, equals 24. Equals 24, okay? Now, let's go back to our mini mega, and we're going to start at the top. Find the expression. Well, honey, we got a big expression right here. We got a big one. There's the expression, and it's a big one. But that's our expression. So there, next step, distributive property. We don't have any. Skip it. Label the constant terms and the variable terms. So I'm going to label, this is a variable term. This is a constant term. This is a variable term. Go ahead and get in the habit of picking up the sign with it. Variable term, constant term, variable term, constant term. Okay? Now it says combine like terms, because we got to have one C and one V to move on. So to combine these like terms, I'm going to sort them like we did. I'm going to do variables right here and constants right here, just to get my head in the game, okay? So there, I've got an X. I have a 3. I have an X. I have a 3. I have an X. I have a 3. I have one more X and one more 3. So now I've sorted them just like we did when we were combining like terms. I sorted them. And now what do I have? 1, 2, 3, 4 X's. And 1, 2, 3. That's 3, 6, 9, 12. So this becomes 4x plus 12 equals 24. Okay, let's see. Look at that. 4x plus 12 equals 24. Okay. That is, we had to combine like terms to get there. This was using combining like terms to get there. So we'll label this all just by itself. We had to combine those like terms to get to this. And this matches what we have highlighted right here, which is where we want to be. That's the equation we want to get to. That's our, what I call be all end all. That is the one. I think one year I had my kids said, we got to get to the easy equation. They ended up calling this the easy equation. If we can get everything down to the easy part, then we can finish. So that's kind of what they used to say. Now here's the other equation that we're looking at. So we did this one. Now let's do this one. All right. Now let's do that one. 4 times x plus 3 equals 24. Okay, now. So that, we got our equation. Let's get over here. Find the expression. Here it is. Use distributive property. If necessary, do the distributive property. Well, I'm going to tell you right now. We got distributive property to do. And the way that we know we have distributive property is these parentheses right here with an expression on the inside and a number on the outside. This is how I know I have to distribute. Okay? That's how I know. This is my that there's the distributive property. That was supposed to sound like an alarm, did it? Are y'all giggling? You miss me, don't you? All right, so let's do it. And we're going to do the distributive property the shortcut way. We're going to do 4 times x. 4 times x is 4x. 4 times 3 is 12. So we have 4x plus 12 equals 24. Well, hang on a minute. Wait a minute. Look at there. Look at this. And look right there. There and there. We're there. We're at that sweet spot. We're at the spot where we want to be, where we can now continue with our mega map. Okay? Now we have, so you've seen an example of what it looks like to go from the distributive property all the way down to now we're ready to do this. Or combining like terms and we're ready to do this. But either way, we are now right here. Well, we got to get our C and our V. Well, no, we're going to go back to the top and do this one. We're just going to go back to the top. But when you put all of these steps together, you won't be going back and forth to the top. But on this one, we distributed and we got to this point right here. And now we're fixing to pick up with that right here. On this one, we combined like terms. We got to this point right here. Now we're going to pick up right here. So we're right here. We've combined. So we have combined like terms. And we're ready now to go from here. And all I was trying to show you is that this equation and this equation will both simplify. These two equations will simplify to get you to this equation right here. Those two they have to be simplified using these steps from here up is just basically you're simplifying. This step right here, you are simplifying the expression to get it to where we can solve it. This is an extra step that Ms. Bosworth put in because it helps you in identifying the constant, the variable, and how to get started with the zeroing out. This combining like terms step right here is another simplifying step. We're getting it a little more simplified in order to be able to get to here. This is where we want to be. This is that point on our map, and that one is green on our map. That one is green on our map. So I'm going to just kind of, and I think maybe I made it green on purpose. Green is good. Green means go. Green means we are good to go. Okay? That's what green is. And we want to get it to here where it is a two-step equation and turn it green so that we are good to go. Green is good. Okay, so we simplified. Now we're here. The one thing that we hadn't done right here that we would have done back up here on this step is we would have labeled our variable terms and our constant term. And we did that over there when we did it. Variable term, constant term. So we're there, and now we're here. We've simplified, and we're ready to do this. So we're going to use inverse operations to zero out the constant term. Here's our C. It is a plus 12. To zero out a plus 12, I have to use a minus 12. And right here, if you look, I told you this step will always be an addition, or it'll be either a plus or a minus every time. It will always be zero out is always plus or minus. So I'm going to undo. This is undo. Now I need to balance. And I balance by putting a minus 12 over here. Remember, your equal sign is the middle. Okay, when I do that, my 4x needs to be brought down. And 24 minus 12 is 12. But I'm not going to rely on my mashed potato brain because I'm hungry and I'm tired. And I am going to make sure that I did it right. I'm going to check myself with my calculator. Okay? So we've done that step. Now we're ready to use inverse operations to undo and balance. Again, this step will always be a multiplication or division. 4 times x is what's being done right here, and I need to undo that. I want to undo that with division. So I'm going to divide by a 4, and I have to balance on the same side the same way. So I'm going to divide by 4. When I divide that, I get my positive 1 coefficient for my x. And when I do this, I get a 3. And there is the value of x. That is the value of x. All right. Pause the video. Do whatever you need to do. We're not gonna do number 12, so you can just kind of mark it off for now. We're gonna jump over here. We're gonna work these. You're not drawing these. You don't have to draw these. We're gonna work these with our steps. We're just now we fixing to do some steps, and I'm gonna talk you through these steps exactly the way you need to talk yourself through them. I want you to write up here at the top of your map, self-talk. You're going to be talking to yourself, period. You're not going to be talking out loud, but you are going to be talking to yourself and telling yourself what to do right here. This is going to be telling you what to do. I almost feel like sometimes I should have made these conversation bubbles, but it wouldn't have been a thinking map then, would it? All right, so we start right here. Starting right here. Identify the expression. The expression is right there. Your expression will always be, let me make sure we're focused. The expression will always be what has the variable and the constant in it. Do we have any distributive property? Nope. Moving on down. Label the constants and the variables. Well, here's a variable term. Here's my constant term. I want you to be able to see those real good. Variable term and constant term. Now we're going to combine like terms. Won't have any combining like terms. We have one C and one B. One C, one B, we're good to go. We're ready. We can move on. Now we're ready to use inverse operations to zero out the constant term. We've got to undo right here. Undo with a -1 and balance with a -1. We have to do the same thing on both sides. This becomes a 0. We bring down the 2y. This is 16. We have our new equation. Now we're ready to use inverse operations to undo and balance. This step will always be multiplication or division. So we're going to undo. 2 times y can be undone with dividing by 2. We're going to undo this multiplication with division. If we undo the multiplication with dividing by 2, if we undo the multiplication with dividing by 2, we've got to balance by dividing by 2. So we have to do the same thing on both sides. This is going to divide and give me my +1 coefficient for y. This divides and gives me an 8. And you've just solved that equation using the steps. You've just solved that equation using the steps. Okay? So let's take a minute, pause this if you need to. And while you've got a minute and while we're just take a minute, and down at the bottom somewhere, I want you to tell me something, I don't know, just put something interesting, something cute down there, just something to let me know you're listening. Something to let me know you're listening, that you're still with me, that you're listening, that you don't have closed captions on, and you're just, or that you don't have anything on and you're just watching me do what's on the paper, and you're not really listening to the instruction. So just write me something down there. I'm grabbing some more colors, like I don't have enough already. All right? I don't know. I just felt like a different color pen. Okay, so now here we go. Let's do this one. We're going to start at the top with our self-talk. Find the expression. Find the expression. Here it is. There's our expression. Distributive property. We don't have any. Move on. How do we know we don't have any? We don't have those parentheses. Label the constant and the variable. Here's my variable term. Here's my constant term. Combine like terms. I don't have any of that either. I've got my 1C and my 1B. So I'm ready to move on to the next step. Now I am going to zero out the constant term with undo and imbalancing. So I've got to undo this +2 with a -2. I've got to undo the +2 with a -2. If I do that, I've got to balance with a -2 right here. I'm going to bring down my variable term. That becomes a 0. It's gone. And this is a 9. Now, I'm ready to move on to my next step. I've got my new equation right here. And I'm ready to move on to this next step, which is using inverse operations to undo this 3 times v. I've got 3 times v, and I need to undo that. I'm multiplying by 3, so in order to undo that, I have to divide by 3. Remember, we're using the horizontal fraction bar to show division. Then I have to balance over here with dividing by 3 again. This is going to divide and give me a positive 1 coefficient with my v. This gives me 3. So v equals 3. V equals 3. All right. Now, we've done several of these. You've got a lot of information right here, and we are probably coming up on the end of class. So, I do want you to finish this. I do. And I do think I do want you to do some of the others and look at the, let's do, I want you to just X out slide 16. X out slide 16. I want you to do this one. I want you to do this one. So let's put a star by this one. You're going to work that one. And I'm going to be looking at that one. I'm going to actually look at that problem. When I take your paper, I'm going to look at it. So I want you to do that one. We're going to X out slide 16. And I want to look at slide 17. Okay? Timothy drew a hanger model for the story problem. Lynn had 90 flyers to hang up around the school. She gave 12 flyers to each of the 3 volunteers. Then she took the remaining flyers and divided them up equally between the 3 volunteers. Okay? This is the model he drew. Do you agree with Timothy? Explain your thinking. So I want you to do that one. I just want to see what you have to say about that. Okay? We're not going to do this one right now because we're going to come back and do some word problems later. Okay? So that's pretty much where we are. I want you to do this. Do what we did here. You're doing this one. And you're going to just tell me what you think on this one. And I'm going to look at those when you turn your papers in. So make sure that you have all of this done. We did all this. The other we did in class. Most of this we did in class. If we have time, or I will have a finished version of this for you on Google Classroom with all the answers when I give them back to you with signed papers. So that's where we are. And if you if you get through with this and have time left in class, you're going to do your numerical reasoning on progress learning. So have a great weekend, and I will see you on Monday.